So today we're going to learn how to solve a system of equations using the substitution method. We're going to do two examples. This first one is of what we call a linear. Both of these are lines. So in either case you need an x equals or a y equals. And so we look at the equation and we decide which situation would be the easiest to get an y equals. So if I look right here, I can see that all I'd have to do to get a y equals is just subtract 3x on both sides. So now I have y equals 15 minus 3x. And so that is what I'm going to use to substitute with. I'm going to substitute into the other equation for the y. So this is what it's going to look like. And we'll have 8x minus 4. But now I'm going to substitute that expression for the y equal 20. And now I'm going to be able to solve this just using regular solving techniques. So I have 8x minus 60 plus 12x equal 20. That gives me 20x minus 60 equal 20. I'll add 60 to both sides. Gives me 20x is equal to 80. Divides both sides by 20, and x is equal to 4. Okay, so now I don't know what x is, but I've got two equations and I've got two variables. So x is 4 for this situation, so now I need to substitute again, but this time back into my little equation here. It says y is 15 minus 3x, and x is 4, so y is going to be 15 minus 3 times 4. So y is going to be 15 minus 12, y is 3. So my official answer is 4, 3. And I can check this. So if you want to check your answer, then just remember you have to plug in your point, your two variables, x and y, into both equations, and it must work both. So here we go. So we'll do the first one real quick. We will check the first one, and so 8x, x is 4, minus 4y, and y is 3, that is supposed to be equal to 20. So let's check to see if it is. I get 32 minus 12, which is in fact 20. So it does check the first equation. So now I'm going to check the second equation. Same two numbers, but in the second equation. So the second equation says 3x's, or 3 times 4, plus y, y is 3, is supposed to be equal to 15. And again, let's check to see if it is. And I get 12 plus 3, and of course we know that's 15. So it checks both. Okay, here's another example for us. We still want to use substitution. That is still the method we're practicing here. But this one is a little bit different. So we still need to have an x equals or a y equals, and in this case I think I want to get an x equals. Looking at that first equation, x minus y equal 1, all I'd have to do is just add y to both sides to get x equals 1 plus y, or if you prefer, y plus 1. And so that's what I'll use for my substitution. So now in the second equation, I'm going to put this 1 plus y in both of those places. I'm going to substitute that in for x in both of those places. So it's going to be a 1 plus y squared minus a 1 plus y times y minus y squared equal negative 11. So now I'm going to have to solve this equation, this big fancy thing for y. and I'll have to do some scratch work and some other things, so let's go over here and start. The first thing I need to do is 1 plus y squared, so that's 1 plus y times 1 plus y. If you need to stop the video and pull that out, you can, but I'm just doing it over here in my scratch work. That'll give me a 1 plus y plus y plus y squared, so that's 1 plus 2y plus y squared. Alright, let's put that back in my problem. Okay, now my second thing I need to do is this. Okay, I need to do this. I got over here in my scratch work. That's going to be y plus y squared with a negative in front if I distribute that way. So that's going to be a negative y minus y squared, and then I have another minus y squared equal negative 11. Okay, so now this looks like it might be a quadratic, but that's the substitution, and now I'm in the process of simplifying and getting it all in order. So let's get our like terms together, and let's start with the y squared. So y squared minus y squared minus another y squared, so that's going to be minus y squared. Let's look at the y terms. We've got two of those, so it'll be plus y. Okay, and then I've got a constant of plus 1, and that's equal to negative 11. Alright, this is definitely a quadratic, and so we've got to make it say set equal to 0. Okay, so to do that, I would just add 11 to both sides. So I have negative y squared plus y plus 12 equals 0. Alright, I don't like this. I don't like this negative right there. Okay, so what I'm going to do is I'm going to factor it out. Doesn't have anything to do with any of my work. And I didn't mean for that to be yellow because you can't see it very well. But so what I have here is I have a negative 1 times y squared minus y minus 12 equals 0. So now I need to solve it, and if I think about it long enough and look at it, I discovered this is factorable, and 3 and 4 are going to be my numbers. If you need to review factoring, you need to stop the video, go ahead. Again, that negative 1 has nothing to do with my problem, so I don't have to worry about it. And I'm going to get two answers. I get negative 3 and I get positive 4. Okay, so now I got two answers for y. So I'm going to get two answers for x. So when y is negative 3, remember x is 1 plus y. So when y is 3, x is going to be, negative 3. There's something right. X is going to be negative 2. So that's the answer, negative 2, comma, negative 3. And then the second y, when y is 4, x is going to be 1 plus 4. So x is going to be 5. So my other answer is 5, 4. So two answers this time. And I could check it, but I'd run out of video time. So check it, let's see if it's right.